In this lesson, we're going to take a step back from our FMOD commands and take a look at some of the other scripts in our 3D game kit. We're going to be talking about how we can interpret code written by other programmers that we may be working alongside of. We'll also be talking about when we might need the help of other professional programmers to implement our audio to produce the best results for our music and sounds. Now, don't worry though, because we'll also look at some methods we can use if we have to implement audio into someone else's script. So far, we've implemented 5 different events into our game, and whilst they've varied in difficulty level, they were all done completely with new original scripts that we created ourselves. They were done using the tools that both Unity and FMOD provide us with, and we haven't needed to take information from other scripts from within the 3D game kit to make them work. However, eventually when implementing audio, we'll usually get to a point where we need to use the game's mechanics to influence or control our audio in some way. Now this could be to trigger an event, adjust a parameter, or apply an effect to an entire soundscape. Now, if we were using a custom-built game engine instead of Unity, most, if not all of our events would have to be implemented to fit within the game developer's code and systems they've built. Because of this, we're going to need to recognize the difference between audio that we can implement ourselves and audio that will only work if integrated with other game mechanics. So to understand these different concepts of audio implementation further, I've designated the names General and Custom Implementation to the following definitions. Now the first, General Implementation, refers to audio that can be implemented into a game and work as intended, whilst only using tools provided to us inside Unity, FMOD and any other program we choose to make our games with. As mentioned earlier, all of the FMOD events we've implemented so far can be considered general, as we only used code we've wrote ourselves in order to listen back to them at runtime and make them change dynamically to suit the game. For example, we implemented sounds to the teleporter object in Unity without us needing to know too much about how it operated, how it took the player from one scene to another, and how the code behind all of that was written. Now we did use its trigger area for our sounds, however, as that is a tool that Unity provides us with, it can still be considered general implementation. Custom implementation, on the other hand, refers to audio that requires the use of a system created by code that was written specifically for the game we're building in order to be played as intended. Now this is often needed for audio that is to be changed in some way, such as with automation in real time, to sonically communicate a game-specific mechanic to the player via the audio. An example of this would be the sound of a car engine rising in pitch in a racing game as it picks up speed, telling the player that they are increasing the engine's RPM, something that the developers had to create code for and design themselves. A good example from our game might be dynamic music designed to change whenever our player enters combat with an enemy. Obviously, to change our music in this way, we'd need to know what is considered combat by the game's code. Does the player have to be within a certain radius of an enemy? Does the enemy have a blind spot and won't attack if we stay within that spot? Will the enemy turn aggressive instantly, or does the player actually have to engage with it first? On top of all this, how is it interpreted in the code? Is there a function that checks for all of these conditions? Is there a Boolean variable that represents when the player is in combat? There might be a lot more for us to consider. So what can we do if the audio we're implementing falls into the custom category? Well, it depends on the event and how it has been designed to work. Now, in order for us to discover what our event instance needs to work, we're going to need to learn, even at a very basic level, how to understand code that controls our game's main features. So in order to demonstrate how you might read through a foreign C# script, I'm going to be taking a look at the player controller script attached as a component to the Ellen game object that the player controls in our 3D game kit. I'm then going to show you some things you can do to learn what's happening inside this script and any others you might come across. Okay, so here we are inside the player controller script, and the first thing we can do is actually very simple. Check the names of the variables and the functions. Now, as we can see at a first glance, this script is using a lot more variables than we usually do, all of which have been named to represent their purpose. And we can see from the first group of variables, we have names such as jump speed and gravity, so these must be used for Ellen's physics and controls. Now, we can see they're both float variables based on the data type declared and the values that precede them. We can also see that these have all been made public. Now, this could be for 2 reasons. One is that they are to be interacted and tweaked tweaked with by other developers in the Inspector tab in Unity, which can be helpful for testing out how Ellen feels and reacts to physics in-game, and to be able to quickly adjust the values. The second reason may be to allow these variables to be used by other scripts. So in another script on the Ellen game object, we'd be able to create a reference variable of the player controller type, just like how we made variables of the transform and the rigid body type in the 3D event positioning lesson. Then we could use the get component command in, say, the start function to get an instance of this script, and then we'd be able to access any of these variables by referencing this script using the dot operator next to it and the name of the public variable we would like to access. So for example, we might call our variable that holds a reference to this script PC, short for playing controller. So if we were to write it out to access the jump speed variable, we'd write pc.jumpspeed. Now the most obvious way to find out the purpose of a section of code is by reading programmer notes. Now, as we learned back in the C# basics lessons, we can write notes beside our code without affecting them by writing 2 forward slashes followed by our message. This is something that becomes more and more common and important when working with bigger scripts and larger development teams, as sometimes the names of functions and variables don't make things clear enough. So if we scroll down slightly, we can learn a little bit more about these variables and how they're used. Now, we know, for example, that the m_ready to jump boolean variable is probably used before allowing the player to jump. If it is true, the player is able to jump, and if it is false, the player cannot. If we then take a look at the notes beside it, we can see it says whether or not the input state and Ellen are correct to allow jumping. So whilst at this point we're unsure of the difference between the input state and Ellen herself, we now know that there are at least 2 conditions that need to be met for our variable to be set to true and to allow Ellen to jump. Sometimes we might want to learn about how a variable is being calculated to see if we need it for our audio events. One way to learn about how a variable is used is to simply double click on it. This will then highlight any references to or use of that variable in the script. So let's take the m_isGrounded and the m_previously grounded booleans as an example. Now we already know, thanks to the programmer's notes beside them, that isGrounded is being set to true whenever Ellen is touching the ground, and that previously grounded is being set to true only if Ellen was touching the ground on the previous frame. So now we already have an idea of their relationship. We can then deduce from this that when the script is run for a single frame, the isGrounded boolean would be calculated. If it were run for another frame, the previously grounded boolean would be set to whatever the result of the isGrounded boolean was in the last frame, whilst isGrounded is calculated again for the current one. But how is our code able to detect this? Well, let's double click on the variable and let's start scrolling down until we can find another reference to it. So if we keep scrolling down, the first time we see it is here in the fixed update function. First, note that the fixed update function works exactly the same way as our update function. The only difference is that fixed update runs at a consistent 50 times a second, as opposed to a flexible 60 that depends on the performance of the game, like in the update function. So this makes fixed update a bit more stable of a function for running physics-based code. Second, note how our previous bool is being set to match in value whatever our isGrounded boolean is. Now this might seem a little confusing, but we can note that this is being set at the very end of the update function. And this kind of makes sense, as it means that when the next frame begins after the current frame ends, the previous bool will remain set to whatever value was considered current in that moment. So during the time a frame exists, after everything else in this function has been called, performed, and done by the script, it will finally set the m_previously grounded boolean to be either true or false depending on the value of the m_isGrounded boolean, so that when the next frame rolls around, we'll have the information of the previous frame stored inside the m_previously grounded boolean ready to be used elsewhere. Now if we double click on the m_isGrounded boolean and scroll down a bit, we should see it being used in a function called calculate vertical movement. And most of the time we can see that it is being used as a condition inside of if statements such as this one here. But inside of the third if statement, it is also being set to false. Now if we read through all of these programmer notes, we learn that this top part of our function is using if statements to check to see if it is an appropriate time for Ellen to be allowed to jump. We can also kind of learn this from the variable names themselves, such as m_ready to jump. And we can see in the first if statement that it will only be set to true if the player is on the ground and is not pressing jump, as the name jump input suggests. We can also see in the second and the third if statements that if the player is grounded, and by extension if the player has pressed jump, the player is ready to jump and is not currently in the middle of a combo move, the code sets our isGrounded boolean to false, as presumably the player has now jumped into the air. Now if we double click on the calculate vertical movement function and scroll back up to our fixed update function, we can see that this function is called before our previous ball is set each frame. This means that our code on each frame checks to see if the player has jumped. If they haven't, isGrounded remains true. So then the previously grounded boolean is also set to true, as it takes the value from the isGrounded boolean. Then once the current frame finishes and a new one begins, calculate vertical movement is obviously called again. Now let's say this time that our calculate vertical movement function discovers that the player has jumped and then sets the isGrounded boolean to false. So now if we were to check either of these two booleans at this moment in time, through other parts of our script or from other scripts that we create, we'd find that our player is currently off of the ground using the isGrounded boolean, but in the last frame was on the ground as the previously grounded boolean is still set to true. And it won't be until the script then reaches the end of the fixed update function and comes back to this line here that it will then set it to match isGrounded again, making it false. Now another method we could use when learning about someone else's code is to write our own. Remember, by writing the debug.log command, we not only feed the value of parameters into our console tab in Unity, but we can also discover when they are being called. And to demonstrate this, we're going to find out more about the isGrounded and previously grounded booleans by writing them in this command. So in between the function that sets the isGrounded boolean and where our previously grounded boolean is set, we're going to write our debug.command. So let's make a little space and we'll put it about here. So let's write debug.log and add our brackets and semicolon. And inside this command, we're going to be sending both booleans into our console at once. Now we can't just reference both of their names and have their values appear in the console tab, as by writing two booleans next to each other like this will give us an error in our code. So to fix this, we're going to write some string data to be displayed alongside our variables to show us which is which and to help us separate them. So in front of our m_isGrounded boolean, we will write in quotation marks IG space as an acronym for isGrounded, and then after it add a plus operator. Then in front of our previously grounded boolean we'll do the same thing. We'll add in quotation marks PG space and add another plus operator. Now let's save our script and see what this looks like in Unity. Now as we can see, because we wrote our debug command in the fixed update function, it is being called every frame in the console tab. We can also see quite clearly that both booleans are showing as true as we're currently touching the ground. But if I were to jump, we can see them both momentarily switch from true to false, and then return to true as we land back on the ground. What we can then do is then take a look through our console tab by using our scroll wheel on the right to check the results for each individual frame. As we can see here, there is a moment where both of them did not match in their result. Our previously grounded boolean was set to false, and our isGrounded boolean is set to true. So this tells us that on the frame before this one, the player was in the air but has now since touched the ground. So if we want to, we can create a new debug command that will only appear when this happens, so that we can see it clearly as we play the game and not have to search through every individual frame. So now let's go back to our script, and this time we're going to write our debug command as a result of an if statement, so that it will only be displayed if the condition is true. So let's write our if statement and check for the moment when m_previously grounded does not equal the isGrounded boolean. Then let's highlight our command, let's cut it, and then directly underneath our if statement, let's paste it back in, making sure that it is indented slightly so that it is recognized by the if statement, and then save our script. So now you'll notice in the console tab that nothing is being sent to it. However, if we now jump, we can see the command gets called twice. It gets called the moment we jump and the moment we land. When we jumped, it said that isGrounded was false, but previously grounded was true. And then when we landed, it said that isGrounded is true and that previously grounded is false. indicating the exact frames she left and retouched the ground. So through that simple chunk of code we added, we get a clear idea of when these variables change and to what values they change to. We could also use these booleans to implement the sound of Ellen jumping and landing on the ground. We could check to see if isGrounded is false and previously grounded is true, so that we know that the player has jumped, and play the jump sound accordingly. And we could do the same if isGrounded is true and previously grounded is false. We could play the sound of her landing on the ground. Now, if you are ever looking through a script to see if a specific term, variable, or function has been used, MonoDevelop and Visual Studio both have a way of searching for that term. Just like inside your internet browser, you can press Ctrl and F on a PC or Command and F on a Mac at the same time to bring up a little search bar in the top right corner. We could do the same in our script, just like that. Now let's say I'm looking for the location of a function that was run whenever the player dies. Well, assuming that that function being used has been given the name die or something similar, we can simply search for it to find where it has been created and declared, as well as where it's being used. So let's type the word die into our little search tab, and it then takes us to the earliest line of our script that contains the word we typed into it. Now, as we can see, that line is within another function called onReceiveMessage. And looking at the word die, we can tell that it is its own function by the fact that it has two parameter brackets beside the name, with what we can assume is a parameter variable being passed into it. Now, if we hold our mouse over that variable, Visual Studio's IntelliSense feature will actually tell us where that variable was created. And as you can see, it was first created in the damageable script component and is being referenced from it to be used for our die function. Let's go back to our little search tab and let's press the arrow to move on to the next location of this term. And we can see it's now taking us to the very bottom of the script where we can see the die function has been declared. Now, if we want to test this function and make sure it is called whenever the player dies, we can add another debug command to test it. So in it, let's write debug.log, and we'll simply write in string data, player has died. Let's also then scroll all the way back up to our fixed update function, and we're going to temporarily remove the debug.log command and the if statement we created earlier, as to not clutter our console with too many debug commands. And of course, let's save our script and jump back into Unity. So what I'm going to do is find our enemy's parent object, and I'm going to reactivate it, and I'm going to deliberately get my player killed so that we can test to see if that message will appear in our console tab. So let's start the game and see what happens if she takes enough damage. So now we're only on one life left, so if we take another hit, we can see the message is displayed in the console tab, just as we predicted. So those are just a few ways we can search through a script that was created by another developer to learn about what each part does. Now that we've learned a few things about our player character script, let's see if we can use it for some custom audio implementation. We'll start with this die function and use it to play the sound of Ellen taking the hit. Now if we jump back into our FMOD project, you'll see that I've already created a 3D event ready to go that's really nice and simple for you to copy. This event is just designed to be played as a one-shot, and as you can see, it contains a multi-instrument that will randomly play one of our audio files of 20 when the player dies. These files can be found under Assets, in the Ellen folder, and the Death folder. If we quickly play it, it sounds like that. So I've already assigned this event to my master bank, so let's quickly hit F7 to build it. Then go back to our die function in our script, and all we need to write is fmod unity dot runtime manager dot play one shot attached in order to play this event in the location that Ellen dies at. So I'm going to quickly go back into Unity. I'm going to quickly click the FMOD tab, go Event Browser, Events, Sound Effects, Ellen die, and copy the event path and paste it into the play one shot command. And also add the quotation marks either side so that it is read as a string. Then finally we need to tell our command which game object to play it at, which is the same game object that this script is attached to, Ellen. So we'll just write game object like that. And let's save our script and give it a test. So now if Ellen dies, we hear her cry out. So that example was obviously a very simple one that we were able to make work with a basic bit of C# understanding. However, sometimes the conditions you're looking for in order to trigger or control your audio might be a little bit more complicated. Sometimes systems for certain mechanics span across multiple scripts and rely on C# features that we haven't yet looked at, such as arrays and lists, constructors, and whilst we have looked at it a little with the use of classes, more object-oriented programming, just to name a few. Now, all of which aren't as easy to pick up and understand straight away as the simple methods we've been using, not to mention how a different game, genre, and development team will drastically affect the script's layout, organization, purpose, complexity, and even more. So sometimes it does become important for us to recognize when the implementation of audio is better left to a person or team who created the scripts and the mechanics themselves so that they're able to fit the audio so that it works best. Programmers will likely know the code they've written inside out and will be able to get a quicker and cleaner result than us, and they won't have to spend the time checking through the code and testing it with the methods we've talked about above already. That being said, if you are in charge of implementing audio at any level, it can be a great help to get an understanding of how the base code for a game works in order to effectively work with it and understand how your fellow developers like to approach certain tasks and challenges. If you're able to understand the code of your game, even if only slightly, it can be a great benefit for both the developers and the audio team to effectively implement audio and help improve how dynamic and interactive it can be for the player. So with all of that being said, when it comes to custom implementation, it's good to know your limits and for the sake of the game's quality, know when to share the responsibility of certain tasks. And with that, you should have a clearer understanding of audio implementation at a deeper level. Now we can implement audio for certain purposes on our own, or we can use other systems built by other programmers to trigger our sounds, as well as any notes left by programmers to learn the purpose and function of the script we're looking at. We can also test the purpose of functions created by other programmers by debugging a variable being used inside them. Now that you've got an idea of how you can approach other scripts, I encourage you to dive deeper into the player controller script to learn more about how our player functions. Specifically, there is a function called play audio within that script that the programmers use to trigger lots of different one-shots for the player, similarly to how we did with the def sound. So I'd recommend you start there, take a look at what conditions are being checked for before the audio is played, when the function is being called, and what kind of data types are the variables made up of, and try sending some of them to the console tab with the debug.log command to see how they work. Once you've done all that, it might also be worth taking a quick look at some of the other scripts to see what tools and techniques you recognize and are being used in them. You might be surprised at how much you're actually able to understand and pick up already. Then once you've done that, take a nice big break, and I'll be waiting for you in the next lesson.